Alright, welcome back everybody. In this video we're going to talk about the first few examples from our summation lesson. Get us reviewed and making sure we understand what summation notation means. Hopefully you read through the little description of some of the vocabulary and what the notation means. Let's look at this first one. We're supposed to write this without summation notation and then calculate the sum. So when we see right here sum from k equals 1 to 4, that means we're going to take all the natural numbers from 1 to 4 and substitute them into this expression in place of k. And then we're going to add all of those together. So first we substitute 1 in there. 3 times 1 is 3 minus 2 makes our first term 1. And then we're going to get our second term by substituting 2 in there. 3 times 2 is 6 minus 2, that's 4. Then we're going to substitute 3 in there, and that gives us 7. And then we're going to substitute 4 in there, and that gives us 10. And then we're done because our upper limit of the summation is 4. And we'll add all those together, and we get 22 for the value of the sum from 1 to 4 of 3k minus 2. We'll do the same thing here in part B. If we look at the summation, we're starting at k equals 2 and going up to 5. So we substitute 2 in here. We've got the quantity negative 1 to the second, that's positive 1, times 2k plus 1. If we put 2 in there, that's 5. We start with positive 5 as our first term here. Then we substitute 3 in there. This right here is going to turn into a negative 1, and so negative 1 times 7 gives us a minus 7. And then we substitute 4 in there. Now our alternating term is positive, and this is positive 9. And then we substitute 5 in there. Our alternating term is negative. It's going to turn into a minus. And we add all those together, and we get negative 4. Alright, on to example 2. Write the following sums in summation notation. So now we're going from particular sums to summation notation. Now I usually like to start my summation with the lower limit of summation as 1, unless I have a particularly compelling reason not to. And then I refer to this as the first term, second term, third term, fourth term, fifth term, sixth term. And this is the value that's being substituted in for k in our summation. So we're finding here the sum from k equals 1 to 6. Now, what am I doing to each of these k values to get the term that corresponds to that given k value? Well, in this case, I'm taking the number of the term, and I'm multiplying it by 2. And so this is going to be the sum from 1 to 6 of 2k. And you can check yourself. Go ahead and substitute the values from 1 to 6 into here. 2 times 1 gives us 2, just like we wanted to. 2 times 2 gives us 4, etc., etc. And so that would be a good summation for this first expression. All right. I'm going to number my terms here. 1, 2, 3. There are 4 terms. So if I write my summation here, this is going to be the sum from k equals 1 to 4. And then I have to ask myself, what am I doing to k in order to get each of these successive terms? And there are a bunch of different ways that I could write this expression. It could be quantity 1/3 to the k. It could be 1/3 to the k. It could be 3 to the negative k. Any of those that generates the appropriate term. All right. On to part C. First term, second term, third term, fourth term, fifth term. So we're going to write the sum k equals 1 to 5. And what you notice about this one compared to the others is that the terms alternate in sign. And so we're going to put an alternating term in there to describe that alternation. And usually I like to use either one of these two depending on the scenario, either the quantity -1 to the k or the quantity -1 to the k plus 1, whichever is required to get the pattern of signs that we need. Now for this, we start off with a positive term and k equals 1, so we're going to choose this one because when we put 1 in there for k, it gives us the quantity -1 to the second power, which starts us off with a positive term. And now that takes care of the plus and minus signs. And now if we look at these, all we're doing to get each successive term is we're taking k divided by 4, or 1/4 k. And this would be a good way to write this sum in summation notation. Alright, let's go on to example 3. We've got some summation rules, one of which there's a typo here. The difference rule should be minus signs in there. Copy-paste error on my part. Oops. So now we're going to use these rules to simplify some expressions containing sums. First, we have a constant multiple rule, which says that if there's a constant multiple inside of a summation, we can bring that constant multiple out in front of the summation. The constant value rule, this is one of my particular favorites. When we take the sum from 1 to n of any constant, the value of that is just going to be n times that constant. The sum rule, which says that if we have the summation of two things being added together, we can make it the sum of one plus the sum of the other. And the difference rule, when we have the sum of the difference of two things, we can take the sum of one minus the sum of the other. Alright, so let's look here at example 3. We're given in this problem two summation values. We're told that the sum from 1 to 5 of a sub k is equal to 8. And the sum from 1 to 5 of b sub k is equal to -6. So we don't actually know what the arguments of our summation are here, so it's not like I can actually find the values of these sums for other values of, for other upper and lower limits of summation. So all I'm going to do is use my properties to find values here. The sum from k equals 1 to 5 of 3a to the a sub k. The constant multiple rule tells me that this is equal to 3 times the sum from 1 to 5 of a sub k. And we know the value of the sum from 1 to 5 of a sub k. It's right here. That's 8. And so using this property, we can find that the sum from 1 to 5 of 3a sub k has to be 24. Part B. The sum from 1 to 5 of the quantity 2b sub k plus 3. So using the sum rule, we can split this up into the sum from 1 to 5 of 2b sub k plus the sum from 1 to 5 of 3. And then further, using the constant multiple rule, we can bring that 2 out in front of the first summation. Alright, and so now we'll evaluate first the 2 times the sum from 1 to 5 of b sub k. That's 2 times, and we're told that the sum from 1 to 5 of b sub k is -6. So 2 times -6 plus, and now we have a constant, the sum of a constant value right here. The sum from 1 to 5 of 3, that's just going to be 5 times 3. And so if we add all that stuff together, we get the value of that being 3. Alright, the difference rule. Now I'm not going to go through it step by step, just know that I can use the difference rule and the constant multiple rule to split this into 3 sum from 1 to 5 of a sub k minus 2 sum from 1 to 5 of b sub k. And then I can substitute the values that I know. The sum from 1 to 5 of a sub k is 8. The sum from 1 to 5 of b sub k is negative 6. So we've got 3 times 8 minus 2 times negative 6. That's 24 plus 12. And so the value of that summation is going to be 36. All right, we're going to stop here for now. And we'll come back in the next video and look at some helpful sum rules and some additional summation things that we can do. See you guys next time. Have a great rest of your day.